This is number 20 on the final review packet. So this says that we have a spring with a spring constant, which is K, of 180 newtons per meter, attached to a mass of 1.5 kilograms, and then set into motion. We're trying to find the period, and then we're trying to find the frequency. So the first thing we have to do is use the equation for period, which is pretty straightforward. It's 2 pi times the square root m over k. Now, we know that the mass and we know the spring constant in the problem, so we can just plug in right from there. So 2 pi times the square root of 1.5 divided by 180. That's going to get us a time value of 0.574 seconds. And that's our period for part A. So, again, pretty straightforward. You just plug and chug. Now, part B is asking to find the frequency. Now, period and frequency have a relationship that is inverse. So that means the frequency is the inverse of the period, and the period is the inverse of the frequency. So that means frequency is equal to 1 divided by the value we got for period. So that's equal to 1 divided by 0.574, which is going to give us a value of 1.74 hertz. So we've got period, we've got frequency. Now, a lot of people mix them up. So it's important to pay attention to which one is which. Now, period is measured in seconds, and that's going to be the time it takes for one oscillation. So one bounce of this system is going to take 0.574 seconds. Now, frequency is measured in hertz, which is the opposite. So instead of being the time for one oscillation, it's the number of oscillations in a set time of 1 second. So this is how we figure out the difference between them.